Hi, everybody. Good afternoon. Good afternoon. You can still do better than that. Good afternoon. Yeah, the potatoes at lunch, getting everybody sleepy. Do I sound really loud to you, or is it just me? Feel good? Okay. So, this one's going to be non-technical, so a little bit more of a soft philosophical talk, which for me actually makes me way more uncomfortable than giving a technical talk. But what I want us to do today is I really want us to think. I'm going to try not to give you an exact direction of what you should think, but we're going to kind of Socratically lead through a few different ideas. And this is AI versus humans, rewriting the rules of success. So before we get in here, who is concerned about AI? Who thinks that the ethical thought, development, and usage of AI is important? Okay. This is the realm that we're going to be focusing in today. But we're going to take a very historical look at AI, the thoughts and the ideas that brought us to the field's foundation. And success. Can I get maybe 1, 2, 3 volunteers to tell me in 1 to 3 words, what would AI success look like to you? How would you measure success of AI? Not the end of the world, yeah. Yeah, okay. Give me another one. Highly controllable, New breakthroughs, innovation, right? So I just heard a couple things. I heard a fear of the existential, right? Of this is going downhill and it's going to be the end of the world. I heard a fear of the need for regulation, the need for control, the need for this to be a human creation that doesn't exceed us, exceed our control. And yet, I heard a conflicting value too of regulation, of control. I heard innovation. And so we start to get these different dichotomies of ideas that start to clash. And how do we think about them in order to move forward? And that's what we're going to talk about today, which I'm going to go through quickly because we have just a little bit of time. Oh, my battery died. It's so sad. Okay, do this the old school way. Hi, everyone. I'm Michelle Frost. So I do responsible AI consulting out of my LLC called Accountable Intelligence. I am also the technical advisor of... I got the... what? It's okay. I'll do this. Thank you. That's fine. I'll stay here. I'll stay grounded. And then I also do tech advisement for the Ethical AI Council of the Center for Practical Bioethics. And if you noticed, this is Wilbur down here. He's very cute. You can give him about 10 seconds of cute waves. Sometimes my brain turns itself off and on again, and should that happen, he is here to help me. So in order to move forward with AI, right, we have to think about how we got here. We need to pause and evaluate where we are today. But in order for us to fully understand our current position, the current present, we have to dissect the historical foundations that brought us here. And through exploring the evolution of AI, from ancient myths to modern technologies, we can better grasp the limitations and the potentials of the field, and what our present metrics are, and if they fully help us capture what we're hoping to accomplish. And Martin Luther King Jr., we are not makers of history, we are made by history. So we're going to go back. Was anyone able to attend Richard Campbell's talk a couple nights ago on the history of AI? Okay, a couple people. So he looked more modern metrics. This is a big field, right? We've got a lot of history here. I'm going to go back to things that we don't often talk about in AI. I'll bring up a couple of things that are modern, but for the most part, we're going to go way back. So on our agenda today, we're going to start off with story time. I'm going to probably skip through a couple pieces of it because in the limitations of time. But I want us to kind of set the field. And I also apologize because I get the sleepy after lunch crowd. So I'm going to ask you guys to stay with me and try not to fall asleep. And then we're going to kind of pair 2 and 3 together. So we're going to go through historical context, and we're going to talk about emerging themes that are coming out of each of these sections. And then we're going to talk about some modern metrics of how do we measure intelligence? How do we measure artificial intelligence? What is intelligence? How do we define it in humans? The brains are interesting, right? We still don't have all the knowledge of how our brains work. It's a mystery that is, you can't touch it, but it's so close, and yet it's one of the greatest mysteries of our time. And if we don't fully understand the thing that we're basing a field off of, where's that going to lead us? So what we have to do is take a socio-technical perspective. We'll talk about what that means, and how do we take that mindset and look ahead. So here's your story time. Who has read Frankenstein? Raise them higher, because I'm... People. Okay. Please read Frankenstein. And if you haven't read it recently, it's actually really interesting to read to read it now and think about it in context to AI. So I'm going to read a couple excerpts here, and I'm going to probably skip a few too in the interest of time. But there's a few different themes that are going to come out. So as I'm reading some of these passages, I want you to think about how would this apply to the here and now. So starting with chapter 4, we have Dr. Frankenstein's insistence on creating this monster. He says, "What I found so astonishing a power placed within my hands, I hesitated a long time concerning the manner in which I should employ it. Although I possessed the capacity of bestowing animation, yet to prepare a frame for the reception of it with all of its intricacies of fibers, muscles, veins, it still remained a work of inconceivable difficulty and labor. I doubted at first whether I should even attempt the creation of a being like myself, or even one of simpler organization. But my imagination was much too exalted by my first success to permit me to doubt my ability to give life to an animal as complex and wonderful as man." Further down in chapter 4, he starts talking about his illness, his sickness, while he is pursuing this task. My cheek had grown pale with study. My person had become emaciated with confinement. Sometimes on the very brink of certainty I failed, yet I still clung to the hope that which the next day or the next hour might realize. One secret which I alone possessed was the hope to which I had dedicated myself, and the moon gazed on my midnight labors, while with unrelaxed and breathless eagerness I pursued nature to her hiding places. Skip forward, so the monster is then now created throughout chapter 4 and 5. It was a dreary night of November that I beheld the accomplishment of my toils. With an anxiety that amounted to agony, I collected the instruments of life around me that I might infuse a spark of being into the lifeless thing that lay at my feet. Skipping ahead, I saw the dull yellow eye of the creature open. It breathed hard, and a convulsive motion agitated its limbs. I had worked hard for nearly 2 years for the sole purpose of infusing life into an inanimate body. For this, I had deprived myself of rest and health. I desired it with an ardor that far exceeded moderation, but now that I had finished, the beauty of the dream vanished. The breathless horror and disgust filled my heart. And he flees. So Frankenstein is gone. Now we have this monster, this creation, that is in this world that it has no idea what to do. And you start following, the next few chapters, you start following the monster's journey through this life. And he goes through, he talks about how he's cold. He doesn't understand that he needs clothes. He doesn't understand the environment, the weather, how it feels upon his skin. He says, "I was a poor, helpless, miserable wretch. I knew and could distinguish nothing, but feeling pain invade me on all sides. I sat down and I wept." And he talks about the first village he encounters where people attacked and fled him, and he's so confused because he doesn't understand their reaction to him. And then he talks about, well, he starts learning things. He starts learning language by hiding and observing a family, learning language, listening to stories that are being read to children at night while he's in his hiding place. He then learns that the possessions most esteemed by your fellow creatures were rich. He says, what was I? Of my creation and creator, I was absolutely ignorant. But I knew that I possessed no money, no friends, no kind of property. I was besides endued with a figure hideously deformed and loathsome. I was not even of the same nature as man. And we'll skip ahead here. That was chapter 13. Actually back a little bit too. He confronts Frankenstein. And he wants an answer. He says, why did you create me? What was your intention of creating me? And when Dr. Frankenstein is so terrified of this creature, the monster itself is trying to create reason, okay? And he says, I expected this reception, said the daemon. All men hate the wretched. How then must I be hated, who am miserable beyond all living things? Yet you, my creator, detest and spurn me, thy creature, to whom thou art bound by ties only dissoluble by the annihilation of one of us. You purpose to kill me. How dare you sport thus with life? Have I not suffered enough that you seek to increase my misery? Remember, I am thy creature. I ought to be thy Adam, but rather I am thy fallen angel, whom thou derivest from joy for no misdeed. Everywhere I see bliss, from which I alone am irrevocably excluded. We could read that all day long because it's a big book, right? Someone give me some themes. Start shouting a couple out. The purpose? Mm-hmm. Rejection. Learning. Fear. Yeah. We could honestly make a huge list here. But some that I think of when I reread Frankenstein. There is the obsession and ambition of Dr. Frankenstein, of his relentless pursuit of creating life. How do obsession and ambition drive technological advancements? It should also serve us as a cautionary tale of the potential dangers of unchecked ambition. Creation and responsibility. As we do create these things, what is our responsibility as the creators? At what point does this extend and when does it stop? What about unintended consequences? What about the tangible risks in AI like bias, privacy issues, values conflict? Earlier we talked about control, regulation versus innovation, those middle grounds that we didn't see coming. Learning and adaptation. Societal integration and impact. We're creating a technology that doesn't operate in a vacuum, right? It integrates with our very lives as humans. So then what are the ethical implications of creation? So we're going to go back, all the way back, to about 750 BC. Is everyone familiar with the story of Talos? So this is actually the first record that we have of a story of an artificial being. And Talos was a bronze man crafted by Hephaestus, commissioned by Zeus to protect the island of Crete. And I think he patrolled the island 3 times, and he protected the island, okay? So there's a little theme there, right? We see that we could have something like us that's more powerful than us to protect us. My Fair Lady, anybody seen it, remember it? Okay, well that's based off of the story of Pygmalion and Galatea. So Pygmalion was a sculptor. He sculpted this beautiful woman, and he became obsessed with the desire that she were alive. So Aphrodite granted this wish. And the Golem of Prague, so this is in Jewish folklore, this is a creature made of clay, and it was brought to life by a rabbi to protect the Jewish community from persecution. It was animated using mystical rituals, and it could follow simple commands. Does anyone know what happened there in the story? Okay, well, it became uncontrollable, and it wasn't good. So even then, we still have this ancient fear about, it's a fascination and a desire to make beings like us, and yet we're skeptical. We want them to protect us, but we're afraid of where that can go wrong. In each of these sections that we're going to go through, I'm pulling up usually about 3 examples. I want you to know there is a list. There is a long list of all these different examples throughout history. Okay? So this didn't start in the 1950s. This is since the dawn of human time, we have asked, what does it mean to be like us? Can we replicate us? So what do these ancient myths tell us about humanity's desire to create lifelike beings? And what responsibilities do they imply for us as the creators? Well, enter ancient philosophy. Again, we could make a list of all these things, but of course, Socrates, know thyself. What is the importance of self-knowledge as essential for making the right decisions and leading a virtuous life? So again, we have concepts of self-awareness, of introspection, that in order to improve and make the right decisions, you first have to know your own character. And then Aristotle and Euclid began ideas that the physical system might be able to operate as a set of logical rules. And if we can replicate that, maybe human thinking could be a symbolic system. I'm going to have a hard time pronouncing things today. Syllogistic logic. So how do we draw conclusions from premises, right? What is symbolic reasoning? And of course, for my math nerds out there, the father of geometry came up with the greatest common divisor. Why is this important? It's the first algorithm, okay? And we start getting these ideas of algorithms. We can start representing things as logic and as rules. And as these schools of thought are being formed, questions start arising with them. Is there a divine algorithm? Is the body a complex machine? Is the mind a complex machine? What is the connection between our mind and the physical realm? And if thinking can be represented by a symbolic system, are humans just complex machines? What does it mean to be us? Well, a couple early modern philosophers started trying to answer that question. Actually, a lot of people did. Again, these are just 3 examples. Of course, by reasoning, I understand computation. Hobbes viewed reasoning as a form of computation, equating human thought processes with mathematical operations. Thus, cognitive processes might one day be replicated by machines. And René Descartes, from the Meditations on First Philosophy, I think, therefore I am. How do we know for certain that what we perceive is real? How could we verify our own consciousness? And of course, there were a lot of different studies and musings on how to do this. I won't get into that. But what proof do we have that what we feel and perceive is real? Descartes also argued that if we were ever able to mimic a human as a machine, which Automata, we'll get into that here soon, it would never be able to pass as real because it would lack a mind and therefore a soul, according to his argument. And then Leibniz, the human soul is programmed. He was a German mathematician and philosopher that argued that the mind is a container and the body is a complex machine, but it is one with a set of divine instructions. Start seeing the link here, and our friend will come back later in the story. So, could machines ever possess true understanding and consciousness? What would that look like? If we can't verify our own, how would we start verifying it in a machine? Early engineering was a fun time. Couple examples of my favorite. We don't have the word robot yet, right? So we call them automata. The mechanical monk, 1560. A Spanish clockmaker, Juanelo Turiano, he created this monk as a gift for King Philip II of Spain, whose, I think, son was sick and miraculously recovered, and so it was a gift. And this monk could walk across the table. It beat its chest in contrition. It moved its lips in prayer. It had a rosary that moved up and down. It was clockworking. It was early mechanical engineering. But it, sat on the table and people went, "What the fuck is this?" It can do things that we can do. What else can we make? Enter into this fascination with replicating human behavior. We saw Automata that painted, that wrote, that danced, that did all sorts of things that humans do. My favorite, does anyone know the backstory of the phrase, "if it looks like a duck and it walks like a duck"? So, huh?
It must be a fish.
Yeah, exactly. Yeah, that is exactly how it ends. There's a long story behind that phrase of when it became popularized, which was actually more recently, but it was founded in the 1700s. An engineer, French engineer, Jacques de Vaucanson, created a bronze digesting duck. And it had 400 different moving parts, so really it was a feat of engineering. And you could feed it these little pellets, and it would walk across the table and shit. We start things in fun, right? But again, people start questioning, okay, well, this has the functionality of a duck. What makes it not a duck? And then perhaps the most famous was the mechanical Turk. This was a machine in the 1700s that could play chess, and it was a marvel across Europe. It beat very fabulous chess players, and people were astounded by it. And it turned out to be a hoax. There was a man behind the curtain operating things. But think about that fascination that we had in even the 1700s and even the 1500s with replicating human behavior, with beating humans in the things that they're good at. And it starts to leave these questions. Well, if we can build machines that mimic aspects of human behavior, could we one day build a machine that would replicate humanity? There's a lot of different mathematical and computer science breakthroughs, but let's just talk about a couple of them. So earlier we met Leibniz, who invented then the step reckoner. And it looked basically like a billiards table. It had balls, holes, sticks, and canals. And it was an early mechanical calculator. Okay. And of course, then we had the early musings of the analytical engine. It was never completed in Charles Babbage's lifetime, but it featured key components in the design that are present in modern day computers. And of course, I have to mention Ada Lovelace, who in the footnotes of the work she completed with Charles Babbage is then thought to have invented the first algorithm. And she also imagined and foresaw that computers would one day be able to manipulate symbols to create music, art, and more. So do these early mathematical inventions maybe suggest that human cognition could be fully mechanized, or could there be aspects of human thought that remains beyond the reach of machines? And of course, we have computer science breakthroughs. We all probably know most of these. Granddaddy Turing had quite a bit of work in... I can't look at you and not giggle. He had quite a bit of work in, obviously, the universal Turing machine, and we're going to talk about the Turing test, of course, here soon. Boolean logic. Again, we had all these ideas and frameworks that were well before their time. And it wasn't until later on when people started to figure out how to use these things that we started being able to move quickly. And of course, we have to mention von Neumann, stored program concept, right? What's that one? Anyone? It's memory, right? What's one of the things that make us human? It's our ability to have memory. So could the theoretical foundations laid by these early breakthroughs fully capture the complexities of human intelligence and consciousness? What is that? So we're going to skip around a little bit, but let's talk about the public perception. Because on the backstory, you have all these different fields, right? And they're really asking the question, what does it mean to be human? And can we figure out what it means to be human through our own individual fields by making advancements? But you have the public that has its own thoughts. So the word robot first came to us in a play, Rossum's Universal Robots in 1920s. And the play explored the creation of artificial life and the potential consequences of such creations. And the robots in the play, they eventually rebel against the human creators, and it led to the extinction of the human race. Story we're all well acquainted with now, right? Was anyone here taught the 3 laws of robotics, maybe in school or in a programming class? We know Asimov was a science fiction writer, right? So the 3 laws of robotics, a robot must not harm a human or allow a human to come through harm through an action. It must obey human orders, and it has to protect its own existence. The caveat to rules 2 and 3 is that they can't conflict with the former rules. And later he went in and added a level 0, which is like, don't kill humanity. And the public got really worried about that. We're creating a framework of laws that talks about the potential of the killing of humans, harming humans, of humanity. Shit. I was taught those rules in my undergrad, my computer science undergrad, with no context that this was grounded in science fiction. Why? Why are we still taught something that was grounded in science fiction? It's because it's all we have. It's a framework, right? But also, it's on that existential side, right? We still have tangible risks. We have a spectrum. We'll skip forward a little bit because I obviously have to mention HAL 9000. Please tell me everybody has seen A Space Odyssey. If you haven't, you have homework this weekend. So this was a film from the 60s, featured HAL 9000. He was a sentient computer that controlled the spaceship Discovery 1. He had a very calm voice. It's nice to listen to, but then he had a malfunction and oops. And already, so again, we're raising these profound questions of ethical and existential questions about the relationship between humans and intelligent machines. And when we look back at this, we have to say, how has science fiction and popular culture shaped our expectations and fears about artificial intelligence? Do those fears detract us from the issues that we already see today that we've had for the last few decades? In 1949, in the London Times, Alan Turing was quoted saying, "I do not see why the machine should not enter any one of the fields normally covered by human intellect and eventually compete on equal terms. I do not think that you even draw the line at a sonnet, though the comparison is perhaps a bit unfair because a sonnet written by a machine will only be better appreciated by another machine." That was 1949. In 1950, Alan Turing came up with the imitation game, what we now refer to as the Turing test. And if you're not familiar with the Turing test, basically it goes like this. You have 3 actors, okay? 2 are human, 1 is a machine. One of the humans is an interviewer, and it's in a separate room, curtain drawn, all that. And then you have another human and the machine in the other room. And their objective is to trick the human wants to collaborate with the other human. He wants the interviewer to understand that I am a human. And the machine also wants that person to say, I am a human. And Turing said, well, when we beat this, I think that we'll have gotten there. This was theoretical though, right? This was 1950. We didn't even have the term artificial intelligence yet. And there is some elegance in it, right? There's a simplicity of it. It doesn't require a machine to perform complex tasks or solve difficult problems, but it requires them to trick and to mimic. The paper was titled, "Can Machines Think?" Is it thinking or is it imitation? Where's the line? I'll wrap this up here pretty quickly. I'm not going to go into the very detailed history of all the different sectors of artificial intelligence, but we officially finally kicked this off in 1956. This was a group of researchers that gathered at Dartmouth to carry on Turing's work after he had passed away a few years prior. And the workshop aimed to explore the possibilities of creating artificial intelligence. They brought in a group of people from many different fields. But do we notice anything about these guys? Not a lot of diversity of experience there, right? Maybe we had diversity of field and schools of thought, but probably not a lot in life experience. And to summarize it, there were 3 outcomes from the Dartmouth conference. Number 1, we should theorize and advance AI through a collaboration of big tech and academia working together. Number 2, this is going to be expensive. How do we commercialize it? How do we get funding? The military was the answer. And also, we will require a network of interdisciplinary researchers. Because at the time of the field's inception, we understood that this was coming from schools of thought and philosophy, from mathematics, from computer science. We need everybody in the room here. We've deviated from that, though, a little bit, right? It's become an engineering playground. We've lost that interdisciplinary nature. So we've moved forward, and we've used this as a framework, but we also have to consider if the original goals and assumptions remain relevant. The field of AI has significantly evolved since 1956. We've had advancements and historical journeys through so many different categories, from natural language processing to early symbolic reasoning and search space enhancements to, did I say computer vision already? Through deep learning, through neural nets, through machine learning. We have so many different segues of research, schools of thought. And they're all collectively under the same umbrella. Does the term artificial intelligence even make sense anymore? So how did the foundational goals set during the Dartmouth workshop shape the direction of AI research? Are they still relevant? The last thing I'll touch on here is 3 different milestones that are deeply regarded as AI success points. Number 1 was when IBM's Deep Blue beat the best chess player in the world at the time. 1997. 2016, AlphaGo. And I put ChatGPT here for a reason. First off, we should make sure that we understand that this is based off the transformer model, right, which was released in a 2017 paper called Attention is All You Need. GPT was a variation on the transformer, and it existed for several years before ChatGPT was released. But the importance of ChatGPT is not that the technology was necessarily new, but that it created an interface for the public to access it. In many ways, it democratized AI, but it also set us on a lightning fire trajectory through where we are today. And ChatGPT has blown off so many of the metrics that we had. People still don't even know how to measure it. So what we need to do is we have to start asking this question. Should we define AI success by human replication, by human failure? Well, how are we measuring intelligence? There's been a wide variety of proposed metrics, and they all fall short in one way or another. So the Marcus test was one of the first to involve assessing AI's capabilities to interpret complex multimedia, right? So how do we get visual, audio, how do we integrate all these different systems at once? But also, how does it interpret nuances such as sarcasm, such as humility, irony? And if you think about that, that varies a lot, even in cultural contexts, right? What my humor is, in the States is going to be widely different from someone else's. We are going to miss cues. And if we do that as humans, how do we measure that in a machine? The visual Turing test was very similar to the original Turing test, but it was specifically designed to respond to visual stimuli. So this was specifically to assess visual cognition, okay? Again, it's important, but is it the entire scope? Lovelace 2.0 test is really interesting. It tries to measure creativity, originality. How do we measure creativity and originality in humans? How would you do that for a machine? There's so much ambiguity in this space. Do we all agree on what success metrics of originality would look like? Do we think DALL-E is original? The reverse Turing test then flipped the conventional Turing test paradigm, basically attempting to deceive the AI system into mistaking human interactions for machine-generated responses. And it offers actually really great insights for us as engineers and researchers into the system's capabilities to adapting to nuanced inputs. But this is more of an interpretive tool rather than an actual measure of intelligence. And then there was the Winograd Schema Challenge, which basically focused on resolving ambiguity in natural language processing. So it measures linguistic precision and contextual interpretation, but it had a pretty narrow focus on language without encompassing broader cognitive abilities or ethical reasoning. So these are a couple of the top metrics that have been proposed in the last few years. Do you think that these are sufficient to capture the full spectrum of intelligence? What is intelligence? I'm going to ask for people to start shouting out word, 2 words. Give me some ideas of what you think intelligence is. Empathy. Emotions. Creative reasoning. Give me 2 more. Problem solving. Complexity. Problem finding. We still haven't even agreed on this. Our neuroscience representative over here, I'm calling you. We haven't even agreed on this in the neuroscience community. What is intelligence? And also, as someone that's neurodivergent myself, we start getting it wrong pretty often, right? There's a lot of ableism in trying to declare what intelligence is if we have this narrow perspective. But we can kind of start deriving some themes, right? Learning and adaptation, so the ability to learn from experience and adjust to new situations. Okay? In AI, we update algorithms and models based off of new data and experiences. The system improves over time. Cool. Sensory, pre-processing, processing, and multimodal integration. So as I stand up here, right, I am responding to light, to vision, to audio, to feeling, to temperature, right? To all these different things that my body, our bodies, all of our bodies take in at once. And that's what creates our experience around us. Currently, I will say, ChatGPT might be able to tell you what cold feels like based off of its collection of input from training data. It might even have, some fuzzy logic around, oh shit, it's 30 degrees Fahrenheit outside, that's cold, put a jacket on. But does it know that feeling? Cognitive architecture and processing. So we have frameworks and processes that support our complex thinking, problem solving, and decision making. Memory, right? Attention, the ability to organize and manipulate information. AI systems need robust cognitive architecture to perform tasks that require sophisticated reasoning, planning, that mimic the intricate processing capabilities of the human brain. Language and communication, of course, the ability to understand, generate, respond to language. Creativity and autonomy, right? Generating novel ideas and thoughts and creations, but also having some ability of self-control that I can make independent decisions based off of a set of goals and constraints and probably my experience. And empathy and ethical thinking. Okay? A lot of times in AI, if I say that we're going to work on ethical AI, eyes glaze over. Okay. Oh, God, the blocker that's going to stop innovation, the fun police. But ethics are subjective, right? They differ in different contexts. Ethics is really a framework. How do we make decisions based off of what we value? Thank you. How do we base decisions off of what we value? How do we create strategies for taking a list of values from different places, from regulation, from the values in our industry, from the values in our organization, our company, from the values that we hold important? And how do we compare all of these into actionable goals in our system? What are we going to do about it? I have 5 minutes left, so I'm going to blow through these next 2 slides. So really, I want to bring it back to that interdisciplinary idea of where we looked at all these different schools of thought and fields that had come together with really the question of what does it mean to be human? Can we replicate ourselves? Should we replicate ourselves? What does that imply? And yet AI innovation has vastly existed in academia and big tech, right? We've lost some of the thinking. We've lost some of the different fields that were involved. People are getting involved now. Last couple of years have been fun. But we need everybody, right? We need an integration of technical and social systems. This is a social technical issue, meaning that this technology doesn't exist in a vacuum, right? It integrates with all of us. Tomorrow, I'll be talking about fairness and bias mitigation. Please come, that's my favorite thing. And I'm going to talk about a technical approach. But we cannot solve bias only through technical approaches because it is a social problem. And yet we're putting technology on top of social problems. So it takes both sides. Issues that have come up, again, like bias and fairness. Do we seek to replicate human fairness? Do we want to generate equity? What kind of technology do we want to bring into the world? How do we create space for human and AI collaboration? Do we want AI to beat us? Where do we want it to beat us? What sort of things would, if it did do, would it augment my time and my abilities versus replacement? Now, replacement is coming, but again, if you look through history, it's not always a bad thing, right? It alleviates some of the day-to-day pressures in order to create more space for us to move forward and innovate as humans. What is that impact? What's going to be the impact on society and employment? Historically, we've always done a really shitty job at forecasting these things, but if we're not thinking about it with intent, we're going to look back and go, oh, actually, we could have probably thought about that one a little bit. So, responsible development. What does that look like? Should ethics be a blocker, or should we slow down at the start so that we can understand where we're going? Do we slow down to actually speed up along the way? Because at some point, if you kick off in running, you're going to hit something, whether it's a lawsuit, whether it's regulation that has changed. At some point, you're going to hit a slowdown. And if you don't care about ethics, perhaps you care about risk management. Perhaps you care about lawsuits. So there's multiple different mindsets and frameworks that we can use to talk about the same thing. And an interdisciplinary approach. We cannot just be technologists working on this problem. We need public perception. We need to understand how people are feeling about this. We need doctors involved. We need lawyers involved. We need people who are experts in their field to say, hey, we've actually kind of talked about this, and maybe could we do that differently? How do we collaborate? So we got to figure out what our current risks are. What are the tangible risks, the tangible problems, versus the long ones down the road? The end of humanity, we are all dead. We're not there yet, but we do have issues today. We have systems today that are impacting real lives. And how do we reimagine AI success? What would that look like? I can't take an intelligence and put it on a linear scale for a human and say this person is 70% intelligent. We create a radial map, right? We say these are all the different categories. We're doing pretty good over here. We might need some work over here. We're excelling over here. How do we spend more energy in this space? How do we create inclusive evaluation metrics to make sure that we're not measuring intelligence based off an assumption that excludes certain people and individuals? How do we create human-centric AI design? NIST has some wonderful frameworks for this, by the way, and Wilbur is snoring, so if anyone else is feeling that, I apologize. And of course, interdisciplinary research, integration, and then policy and regulation. I know that's the dirty word in tech because it means that maybe we're not innovating, but we need guardrails, right? When we kick off a greenfield project, we sit in the room with our stakeholders and we have ideas of what features are going to be the most important. What should we not do? Where should we invest our time? We take the same mindset, but we apply it in a different manner. And I'm going to speed up because it is 2:50. So one thing I'd like to call out, just a project that I'm really passionate about. Again, this is the Center for Practical Bioethics. This is a company based in Kansas City, Missouri, where I live. And we are seeking to work across 3 domains in healthcare to help healthcare organizations implement, build, and purchase ethical AI technology. So we're doing that 3-pronged approach through education and training, through executive level support, through process improvement tooling. If you would like to get a hold of anyone at the center, this is a QR code. And if you want to connect with me, that is a link. So thank you all.